This is the tutorial for Chapter 7, Section 1, titled Zero and Negative Exponents. And so looking at our first problem here, they're asking us to simplify each expression. So they've got this negative exponent. And so what does that mean? Well, the way they got that negative exponent is they had a division problem, or maybe a multiplication problem. So let's start with the division problem, though. Let's say they had 3 to the first power, so just 3 over maybe 3 to the third power. So the way we deal with exponents is we could use subtraction, and if we use subtraction of the exponents when we have the same base, that's how we ended up getting that negative 2 as the exponent. We do 1 minus 3, always take the denominator's exponent away from the numerators. And so that's how they came up with that. So what does this mean? Well, let's go ahead and expand this 3 to the first out. That's just 3. 3 to the third is represented by 3 3's being multiplied together. So you can see as I go ahead and cancel out some common 3's, I got 1 on top, 1 on the bottom I can cancel out. Everything cancels out on top, leaving us with 1. So that makes 1 over 3 to the second. So 1 over 3 to the second equals 3 to the negative second. So what a negative exponent is the reciprocal of positive exponents. So you see I could write this as a fraction, I could take its reciprocal, and the exponents change sign. So to simplify, we want to get rid of the negative exponents, and so that's what we're looking for here. So they just want us to write that in the exponential form just to show that, so we don't have to multiply out the 3 to the second. If you did, that would end up giving us 1 over 9. But I think that in this case, we're just going to leave it in the exponential form. On this next one, we have the same sort of thing, but this time I've got this negative sign in front of the 5. And so what this is a negative 1 times by 5 to the negative second. Typically, we wouldn't concern ourselves with that negative 1 times, but in this case we do, because order of operations says I have to do parentheses, exponents, then multiplication, division from left to right, then addition, subtraction. So you see how exponents come before multiplication. So that's why I have to concern myself with that minus sign in front of the 5. So I take the 5 to the negative second, and I change that to a fraction, 1 over 5 to the second. Then I multiply it by negative 1, and so when I typically multiply by negative 1, I put the negative 1 times 1 and put that on top of the fraction, and that's what I get, negative 1 over 5 to the second power. So I'm going to make that, clear that up a little bit, make sure that looks like a exponent. And so there it is. So negative 1 over 5 to the second power, and that's the same thing again as negative 1 over 25. So moving on to the next problem, this time what's different about this is that the negative sign and the 5 are inside parentheses. So this is saying that negative 5 is to the negative second power. So this would be the same thing as saying 1 over negative 5 in parentheses to the positive second power. So if I was to multiply this out, then I would be multiplying 2 negative 5's, and that would end up giving me 1 over 25. So there's the difference. So you can see how when we have the minus sign outside or next to a number, if it's not in parentheses and you've got an exponent, you've got to treat it as two separate problems there. Now 0 is an exponent. Okay, so let's take a look back at a division problem. Let's say it was, how about, since it's 1 over, I'll do 1 over, and then let's say it was 2 to the second power times or over 2 to the second power. So here's how they could have gotten 2 to the 0 power. So you see they have that 1 on top, that's where that came from. And we have 2 to the second means that we would subtract the exponents again, so to show where they got that 2 to the 0 power. So that's how they got that. Now let's see what this would be in an expanded form. So we had the 1 on top, and then 2 to the second just as 2 times 2, and then 2 times 2 here. You see how these 2's cancel out, leaving us with 1. So that would just make 1 over 1, and that's going to end up being our answer. So the rule is, anytime you have a number, any number to the 0 power equals 1. But this one's a little different because we have that minus sign in front. That's the same thing as negative 1 times by 3 to the 0 power. So again, typically we wouldn't concern ourselves with this situation. But any number, like let's say it's negative 5 without an exponent, is the same thing as negative 1 times by positive 5. It means the same thing. But we have to concern ourselves with that negative 1 times by because we've got exponents to deal with. And exponent rules, or at least the order of operations says we have to do exponents first, then we multiply. So I've got negative 1 times by 1, so that's going to give me a negative 1 as an answer. Now in these problems, they ask us to simplify, so we just have more exponents, and we have variables to the exponent power. So nothing to do with the 4. A is to the first power. If we don't see an exponent, that's the way it is. And then b to the 0, well, that's 1. And so that would just leave us with 4a. So on this one, we always want to make positive exponents. When they say simplify, we want to get rid of negative exponents. So we want to get rid of negative exponents and 0 as an exponent. And the reason why is that way it makes it simpler. We have less things to write down. And so when I have this negative exponent, see how it's in the denominator, to make it positive, it just moves on up to the numerator. So it becomes x to the 7th over 1, which is just x to the 7th power. And then 5x to the negative 3rd. Well, the 5 is actually to the first power. So all I do is I move the x to the 4th down below, and that would be in the simplified form. So only the x is to the negative 4th, not the 5, because it's not in parentheses. Now, it would be different if the 5 and the x were in parentheses. So this would not be the same thing here. So if the 5 and the x were in parentheses to the negative 4th, then we would go ahead and move both of those parts down to the 4th power. And then I could go ahead and multiply out the 5 and simplify it a little more, making 625x to the 4th power. So that's a little different problem. And you can see the difference between the two. The parentheses make a big difference. So let's take a look at this problem here. We have c to the negative 1st. Well, we just switch its location in the fraction, and it becomes a positive exponent. So c to the 1st, or in this case, actually, I'd probably use just c rather than c to the 1st power, because any number is to the 1st power if you don't see the power. So 3 is to the negative 2nd, so that's just going to go down below. Now, when that does, though, we still have 1 on top. In order to keep it as a fraction, that's the way it's got to be. And so that would make 3 to the 2nd over n, which would just be 1 over 9n. So moving on to the next one, we've got two parts here. The k is to the negative 4th, and so I'm going to treat this as a fraction. You can see how that k to the negative 4th is going to go down below. Anything to the 1st, the 0 power, is just 1, so we're left with 1 over k to the 4th power. Next one, we take that negative exponent again, and it's just the x to the negative 2nd because 3 is not in parentheses there, so it's 3 over x to the 2nd y is the answer. The next one here says b to the negative 2nd, so I'm going to move that below. Keep everything else where they're at. The 7 stays where it's at, a stays where it's at, 3w stays where it's at. The b becomes has a positive exponent now, and it's on the bottom of the fraction. Let's take a look at a few other types that we might end up seeing, and here we have to evaluate the expression. So we're going to substitute these numbers in, or actually, before we even substitute, let's go ahead and simplify first. Let's go ahead and make this positive exponent, so it's 3r s to the 2nd power. Now I'll go ahead and substitute. 3 times by negative 3 times by s, which is 5 to the 2nd power. So this makes a negative 9 times by 25. And so when I go ahead and multiply those, I get negative 225. One negative makes a negative. So let's take a look at the next problem here. And it says 2 to the negative 4th, r to the 3rd, s to the negative 2nd. So any negative exponents, we're just going to move into the other location, and then they become positive. So r to the 3rd stays on top. We now have a 2 to the 4th power times s to the 2nd power. So now let's go ahead and substitute. So we'll take the negative 3. Since it's a negative 3 that we're putting in for r, we're going to go ahead and bring that parentheses around it and bring it to the 3rd power. 2 to the 4th power, and then times by s to the 2nd. Well, s is 5, so we have 5 to the 2nd power. And so we go ahead and multiply the numbers out. We've got negative 27 here with the 3 negative 3's being multiplied. Again, that was because negative 3, negative 3, negative 3 make that number. Here we have 16 times by 25. And so that's going to end up giving us negative 27 over 400. It's going to end up being our answer there. So moving on to the next problem, it says to write each number as a power of 10 using negative exponents. And so when I do that, whenever I see 1 over 10, well, that's the same thing as saying 10 to the negative first power. So again, whenever you've got a fraction, 1 over that number, we can write that number as with exponents, and that would be the answer with negative exponents. Well, 1 over 10 to the fourth power makes 10,000. And so the rule with powers of 10 is the number of zeros you see, 1, 2, 3, 4 zeros, that's the exponent that you're going to have on 10 to make that value. Well, if I wanted to write this with negative exponents, then I'd write 10 to the negative fourth power, and that would be my answer. And again, this is the same thing if I put it in the decimal form, which you'll need for the last problem, as this. We'd have 0.0001. Actually, one more 0, 1. So 1, 2, 3, 4. Let's see here. That's 1 over 10,000, so that'd be 4 spaces. So 1, 2, 3, 4. So it'd actually be right here. 1/10,000. So I'm going to get rid of that other decimal point I have. So there it is. So 1/10,000. So again, the rule is we count the number of exponents, or we count the zeros there, and that brings that decimal point over. And so when we read decimals, remember place value, this is the tenths, hundredths, thousandths, 10,000ths. So this is 1/10,000. All right, so those are the types of problems you're going to see on tonight's homework. Good luck.